Good evening and welcome to this presentation. Today I will talk about composite of a function. Okay, composite of a function is simply the combination of two functions. Okay, so now here it is important to note that you have two functions which are defined from a different domain. Okay, so we have a function f which is defined from a to b, and then we have a function g which is defined from b to c. A is the domain of f and b is the domain of g. B is the codomain of f while b is the domain of g, and c is the codomain of g. So here we have a function relation from a to b and from b to c. This right here is g and this one is f. Okay, so from here, for every x, a member of a, we get f of x, a member of b. Okay, so this is the function f of x. Then from this set, which becomes the domain of g, okay, for every element we pick from here, we get g, okay, here, g of f of x, okay. G, this is the function transformation, so g of f of x. Here we have f of x. Here we have g of f of x. Okay, so now this transformation from a to c is called g of f. Okay, it's g of f because it is g of f of x here. Okay, because the domain is his set here, which consists of f of x. So the codomain or the range is going to have g of f of x. Okay, g of f of x is represented by this gof g of x. Okay, so first of all, you have f of x here and you have g of x. For every x, you have f of x. For every f of x here, you have g of x. Okay, so this right here is called the composite of a function. This is a composite of a function, g of x. Okay, gof. This is g of x. This is just gof g of f. It can be g of f of anything. Okay, so you have a function defined from a to b and b to c, where a is a subset of real numbers, b is the subset of real numbers, c is the subset of real numbers. Okay, so let's have an example. Set A is a, b, c, d. Set B is 1, 2, 3, 4, and set C is alpha, beta, gamma, and tau. So we have a function defined from a to b and another function from g to c. Okay, where we have x such that we have f of x here. Okay, here we have x, here also we have g of x. Okay, so now here find g of f of a, then find g of f of b, then g of f of c, g of f of d, and f of g of a. This one we won't do it, we'll do it in the next example. Now look, a to b, b to c. Okay, a, b, c, d, 1, 2, 3, 4, alpha, beta, gamma, and tau. So this here is f and this is g. Okay, so here we are going to have f of a because this is f, and here we are going to have g of something from here. Now what is here? It's f of x. Okay, so this becomes g of f of x. This becomes g of f of x. Okay, so 1 goes to tau, 2 goes to alpha, 3 goes to gamma, and 4 goes to beta. Okay, so this is what we have right here. Now, solution: g of f of a. Okay, this is g of f of a. Okay, first of all, you take f outside. Okay, outside with the a, then brackets, you remain with g. G becomes the main function here. Okay, you take f and a, you group, okay, as f of a, then g becomes the main function. Okay, now what is f of a? F of a goes to what? 2. So f of a is 2. So g of 2, okay, because f of a is 2, so this becomes g of 2. What is g of 2? G of 2. 2 goes to alpha. So g of 2 is alpha. We can conclude that g of f of a is alpha. Now, g of f of b, same thing. We group f and b, f of b. Okay, so this becomes g of f of b, and f of b. Okay, f of b, b goes to 1. So f of b is 1. Since f of b is 1, this becomes 1, and this is g of 1. 1 goes to tau. So g of 1 is equal to tau. Then likewise, g of f of c. This one, we take g and c, f and c. Okay, f and c. Then g outside, g f of c. Okay, g f of c. Okay, now what is f of c? C goes to 3. So this becomes g of 3 because f of c is 3. So this is g of 3. Where is 3 going? 3 goes to gamma. So g of 3 is gamma. So golf of c is gamma. And g of f of c is gamma. Now g of f of d, same thing. F and d becomes f of d, g of f of d. Okay, f of d is 4. Okay, f of d is 4. So this is g of 4. G of 4 is beta. Okay, g of 4 goes to beta, is beta. Now example 2, f of x is 2x minus 1 and g of x is 2x squared. Find g of f of x. Okay, solution. Golf, okay, g of f x, we again take f and x. Okay, so this is g of f of x. Okay, g of f of x. So what is the function g? This is the function g. F of x takes the place of x. Okay, so wherever there's x in this function of g, we replace f of x. Okay, what is f of x? F of x is 2x minus 1. So 2 multiplied by 2x minus 1. Okay, and then we expand. When we expand this one, we will get 4x squared minus 4x plus 1. Then we multiply by 2. This is 8x squared minus 8x plus 2. Okay, I'm sure you know how to expand. Then also b, find f of g of x. Okay, fog. F of g of x, it means first thing you start with g of x. Okay, so you remain with f. So f of g of x is equal to, okay, now you go to the function f. this is the function f, okay? The function f is what? F of x is 2x minus 1, okay? What is g of x? G of x is 2x squared. So f of g of x, so the main function here becomes f. So here, as you can see, g of x takes the place of x. So here you're going to replace g of x, okay? Because g of x takes the place of x here, okay? So when you replace g of x here, what is g of x? Is 2x squared. Where there's x, you replace 2x, okay? So it's 2x squared multiplied by 2, then minus 1, okay? So 2 multiplied by 2x squared minus 1. This is 4x squared minus 1, okay? So note fg of x is not equal to g of f of x, okay? Gof is not equal to fog, okay? Yeah. So that's it with the composition of a function. Unless you have questions, which you can ask. You have questions which we can solve. You can ask. We are going to solve, and we will give the clarification.